For today, we are going to change from what we were discussing about classes. We are going to talk about few things that we left from previous presentations, and some of it are new things. So the first one is about strings. Just a quick review about strings. And for string manipulation functions, I told you before that we need to include the C string for all string manipulation functions. If we have a string like this, char S1 equals, for example, this is OOP, like this. Then there are several functions that we can use to manipulate this string. One of it is, for example, to get the length. How many characters will be there are there in the string? So we can say cout. So to get string length. To get string length, we say cout string len s1. String length strlen. This will give us how many characters in the string. How many characters there? We have here 4, 5, 6, 7, 8, 9, 10, 11. So if we run this one, we'll get 11. So we'll get 11. It doesn't count the null character. It doesn't count the null character. We have also, we used before, if we have here, for example, char S2, for example, let's say 100, and we can copy one string to another. Okay, so to copy strings, we use, as you know before, string cpy s2 s1, which means to copy the content of s2 s1 to s2. Then we have, this is to copy, means to delete whatever there in S2, and copy anything there in S1 to S2. So at the end of this statement, S2 and S1 will have the same content. So here, if we say cout S1 and cout S2, we are going to get the same number, the same characters in both strings. Okay, so we will get the same characters here. This is for string copy. We talked also about what we call string concatenation. String concatenation. There is another version of this one for string copy. For string copy, we can, for example, if we have, let's say here we have char S3 100. Okay, and if we can use another one which is we called string and copy. So we say string and copy and CPY. We want some characters from S1 to go into, for example, S3. So if we want to copy from S1 to S3, but we want only the first, for example, the first 4 characters, which is this. If we want just the first 4 characters, so we will say string n copy ncpy S3 S1 and then 4. This means to copy the first 4 from S1 to S3. And now if we do a cout for these 2 strings, okay, if we do a cout for these 2 strings, S1 and S3, we'll end up with with just the word this. So we have for string copy we have 2 versions. One to copy the whole string from this string to this string, everything. The other one, uncopy, is to copy just one string. Okay. Yes. Okay. One thing here. You see here. Why we got these string characters? Not initialized, but there is how string copy and string uncopy work. How they work. String copy take everything from S1 to S2, including the null character. Including the null character. String uncopy will not copy the null character. So you have, for example, here, okay, you need to add the null character at the end. How to add it? You can, for example, we are copying 4 characters, so we can say S3 4 equals /0, which means the null character. We can do this one if we want. We can also concatenate or something like this, and this is the same way for later we'll see for concatenation. For concatenation, it works both using the same way. So here we have this just we copied one word. Of course, how to copy from the middle? We need to do a lot of things. From here, take this, then cut, then. Huh? No, we cannot ignore. Ignore will not work here. Ignore will only be for the input buffer. Ignore will work for input buffer. another one, we have now the copy, we have the string length here. We have the copy string. To copy, there are two versions. One of them is the string CPY, the other one is string NCPY. There is to concatenate string. Concatenate means to add one string to another. Means to add one string to another. This is what we call concatenation. Concatenation. For example, here we have now S3 contains the word this. So if we say string cat, we want to add S1 to S3. So we say S3 then S1. What are we going to get? Now S3 contains the word this, and S1 contains this string. So we will get this is OOP. You see here currently S3 contains the word this. S1 contains the phrase S1, this is OOP. So it will take this one and add it to the end of S3. It will take this one. So if we here, if we print so we got this is OOP together. But let's say here, suppose here we have from this uncopy we have S3 having the word this. Now if we want to add S3 to S1, okay, to add S3 to S1, we can. We can also add any word from here to any word from here. You can do it, but you can use the string ncat the same way as with string copy and copy. String ncat. So it will concatenate only this string from here, from this. It will not concatenate everything. This string to this string, like put them together. It can just put the first, for example, 3 letters. Suppose here, let's say I say S3 string CPY S3. I say what is. Now in S3 I have the phrase what is. Now I want to take the word this from S1. So I will say string ncat S3 S1 4. So to add just not everything from S1, but just the first four characters in it. Okay, so what is, we had this before, and then it took the word this from S1, So you can build strings this way. So we have string length to get the length, string len. For copy, we have string cpy and string ncpy. For concatenation, we have string cat and string ncat. We have also to compare strings. To compare strings, now I can say compare strings, okay? I can say, for example, if S1 equals S2, then I say C out the same. Okay? I'll print this one, and else I'll say, for example, C out not the same. This is, we'll see that this is not the way to compare strings, but let's see how this will, what will this produce. Of course, it will always, this way, if we do it this way, it will always not the same. No, I think I missed the T here. It will always be not the same. Why? Because here what we are doing is what?
Comparing the address.
Yes, the address where S1 is stored with the address of where S2 is stored. This array is stored in one area of memory. This array is stored in another area. They will never be in the same area. They will never have the same address. So that's why always we'll get, for example, this one. And if we say string compare instead of this one, okay, let's leave it here. Leave this one here. We'll do it in another one, another statement. So here we'll do it with string compare. So we say for string compare, string cmp s1 s2. Now string compare, not like the other ones, it returns a value. String compare returns a value. It will return 0 if they are the same. Okay? So we have two strings. If this string is less than this string, it will be -1. If this one is bigger than this string, it will be 1. How it compares, as I'll explain. Let's say first we'll do this. So we'll say if they are the same, we'll do this first, and then I'll tell you how it works. Okay? So here it says not the same. When we say S1 equals S2, this one it says the same. Okay, because we copied S1 to S2, so they contain the same value in the beginning. Okay. How they work, how string compare works. String compare and it works not like comparing numbers. Not like comparing numbers. It compares the ASCII codes. the ASCII codes. For example, if I have here integer x equals 5, y equals 10, and I say if x equals y, then see out, for example, the same. Let's say like this. Of course, this will not be correct, it will not be the same. What this do, it compares the value of x with the value of 10 numerically as numbers. It will compare it as numbers. But for strings, this is different. Suppose here I have S1 equals, for example, S1 equals, this is OP. And let's say here, of course, we can do it this way when we define a string. We can do it with brackets, and we can do it also with, I'll write it in the other one. We can say S2 equals, this is OOP. Okay? It is the same thing. It is just copying, allocating memory for the string, and then copying the string into that memory in both ways. Here I am using the array notation, and here I am using the pointer notation. They mean the same thing. Now, are these two strings the same? Are these two strings the same? In terms of meaning, for us, they are the same. They contain the same words. But for C++, it is different. They are not the same. So, how does it compare the strings? So, what it will do, the first string, so for example, I say here S1, okay, this is S2, okay. Now in S1, this is T, then H, then I, then S, then space, okay, and then is, for example, like this, and then O, P. Okay, for S2, this is T, this is H. Okay, you see here the ASCII code, this is capital T, and this is small t. Okay, so which one comes first? Let's change it, this one to something that is little bit easy, yani. So you will understand. A B C. Okay, and then here A B C. Okay, and then instead of this one we'll have, for example, this is capital A, B, C here, and then here A, B, C. Okay. Now, when it compares, let's say here I do this one. I say ASCII, and then for the other one, the ASCII. What will be the ASCII for this one, for A? What is the ASCII code for A? It is 65. B is 66. Then this is 67. So now this one is 97, then 98, 99. Okay. So when I say, for example, here, if string CMP S1 S2 equals 0, or let's say instead I say C out string compare S1 S2, what this will print? I said it will print 0 if they are the same. You see here from the ASCII code they are not the same. They are not the same. Now it will print -1 if this one is less than this one. And it will print 1, it will print 1 or return 1 if this one is bigger than this one. So now what it will print? So this will print -1. -1. But if I change, for example, let's say here I'll change this one to capital A. I'll change this one to capital A. Now, what this will print? What this string compare print? -1? But I change it. I change this one A, capital A, capital A. Huh? Okay. So when we have a string like this with more than one character, it will compare the first character with the first character. The ASCII code of the first character with the ASCII code of the first character. These both are the same. They are 65. So now if they are the same, it will go to the next. In our previous example, when they are different like this, since A, capital A is not the same as small a, so it will print -1. And it will not compare the other characters. But if it finds the characters, the two first characters are the same, then it will check the next. It will not come back with -1 or 1 or 0. It will check the second position, the second character. Now the second character is capital P and small b. This is 66, this is 98. So since they are different, it will come back and to tell us that this one is smaller than this one, which means this is -1. Okay. If we put, for example, this one as capital, now the first one is the same. Here A, here capital A, here capital A, capital B, capital B. So it will continue comparing. Then capital C and small c, so it will find that this is less than this, so it will print -1. If I change this one to capital, now the capital A the same, capital B the same, capital C the same, and now this is, we finish this string, so it will mean they are now the same. So it will print return what? It will return 0 here. Okay. Now if I change this one, for example, to small c, Now capital A, capital B, or these are the same. Now I have capital C and, no, small c and capital C. Small c is 99, okay, and capital C is 66. So which one is bigger? Because here is capital C, is small c bigger than capital C? Is small c capital bigger than small c? Yes, it is bigger because it is 99. So this string is bigger than this string. So it will return 1. It will return 1 in this case. Let's say here I'll change this one to C. And then I put this one D here. So what it will return? 1 minus 1 or 0? 0 is not, it is not going to return 0 because the two strings are not the same. Will it return 1 or minus 1? Why it is 1? Yes, D is 100 because C is, no, D is 68 because this is capital D. What about here? What about this string? What is at the end of the string? At the end of this string here. This is C. What is after C? There is the null character. What is the ASCII code for the null character? Is 0. The ASCII code for the null character is 0. So it means 68, of course, is bigger than 0. So it will return 1. It will return 1. And it is the same thing for example, if I put here a 0. If I put a 0, now it needs to compare what? The capital D with 0. The ASCII code for 0 is 48. And the ASCII code for capital D is 68. So of course 68 is bigger than 48. So it will return 1. Okay. So this is how it compares. It compares if you have spaces here. For example, if you have spaces, if you have semicolons, if you have any other characters, it means anything inside there. It doesn't need to be just letters or numbers. It can be any other symbols. Any ASCII code. You can compare any ASCII code to any ASCII code. And it will take the code itself, not the character as we see it by eye. Okay? So this is how the string compare works. This is how the string compare works. And of course, if I say for example here, if I do a string and compare, if I want to compare two strings, but I want to compare only okay, for example here I want S1 with S3 and or let's say S4 and no there is no S4, S3, okay, S3 and I want the first four characters in both if they are the same here. So I use here the n compare. I use the n compare. Okay. Sorry, I think it's supposed to be 4 here, and then here if they are the same I'll put here 0. So for string compare it will compare the first 4 characters in both strings. The first 4 characters in both strings, if they are the same or not. So for example here, okay, you see here, this is what we have. What we have in S1 is this is OOP. What we have in S3 is what is this? What is this? So it compares the first 4. This is W, capital W, then H, then A, then T. And here it takes this one, this. So they are not the same. They are not the same. That's why we got this, it says not the same. But if we change it, instead of S3, if we put, for example, S2, if we put S2, of course it will print the same, because the first word here is this, the first word in here, it is this. So they are the same. This, they are the same. This is how the string compare works. String compare or string uncompare. So we have copy and copy. String copy, string uncopy. String cat, string uncat. String compare and string uncompare. Okay. There is one string manipulation function that is so useful, but you need little bit to understand how it works. It's called string tokenization. String tokenization. String tokenization. Okay, so we know that S1, or let's say, to make sure that string CPY S1, this is, again, this is like, let's say that this is programming. Let's say programming, or let's say I say C++ programming. So in S1 now I am saving this one. Of course, I think I need in here, because I need to give it a size, otherwise it will give me errors, because the size of this is OOP is less than the size of this phrase here. Okay, so now this is what we have. What we mean by string tokenization. String tokenization means to print every word, to split the string into its individual words. To take the words out of the string. So I can print this by itself, then is by itself, C++ by itself, programming by itself. So this is what we call tokenization. Means to split the string into tokens. Tokens means like words, but we don't use the word word, because word means letters, normally letters. Token means anything inside it. Anything can be there inside it, any character. So how the string tokenization works? First, what you need is the string itself. We have the string now. We have the string S1. The second thing you need to define the token. So you say char star token. You define it as, you declare it as a pointer to a character or a character pointer. You define it as a character pointer. This is important. You cannot define it just as characters. You can use anything other than token. I am using token to make it, so that it will mean it will give meaning better than T or S or whatever. Now, the second step. Okay, so the here, let's say here, number 1. Okay, define the string. Okay, number 2, here define the token. Number 3, now get the first token. You need to extract the first token. Okay, how you do it? We use a string manipulation function called string token. So I say token equals string token, means string tokenization. Then I give it the string S1. Then I give it what we call the delimiters. What we mean by the delimiters? Means those that will separate the tokens from each other. What I want, what is now? I want words. Words are separated by what here?
Space.
By space. Not always you need space. You can use some other things. Sometimes characters, other characters. Let's say here I use white space. White space means 3 things: the space, the tab, and the new line character. This is what we call white space. Normally, if we are parsing, we call this parsing. Means if we are splitting text into words, we call it parsing. If we are parsing text, which means that's composed of sentences and words, normally we use this one, space /t/n. It means it will go into this string, and it will copy the characters from it until it finds one of these, any one of them, either a space or a tab or a new line character. When it finds any of these, it will stop. So here, the token, what it will contain? Token will be what? Will contain the word this. The token will contain the word this. Okay? Let's say here, let's say for you to know, okay, see out token. So you will know what it will produce. And by the way, let's say at the same time S1. You will see what S1 will do, what S1 will contain. Okay. This, and it says here this. Okay. Now, where is the remaining, the other ones? Where are the other words? Actually, the other words are there. But what it will do, it is not working. When you do this one, when you do this statement here, this is the first time you do it. This is the first time you do it. You need to take the first word or the first token in a special way. This is the special way. Just you say token equals string talk, then S1, which is the string. Then the characters, the delimiters that you want. This is how we do it. Now, this will bring the first token. The remaining, you need to get it through a loop, normally through a loop. You can do it, let's say here, I can do it in a different, I'll do it first manually. So the second time, okay, we say step 4, get the remaining tokens. Okay, and how you do it? You say token equals string talk. Here, this is the difference. In the first one, you specify S1, which is the string that you want to take words from it or tokens out of it. Okay? In here, you just say null in capitals, and here, /t/m. It doesn't matter, even if you say /n/t, it will work the same way. What does this mean? What does this mean? It means it is telling C++ to continue parsing the same string. To continue parsing the same string. We started parsing S1. We already took this out of it. Now the remaining string is what? Is C++ programming. So I want to continue parsing is the remaining string, which is C++ programming. If I put, instead of null, I put the name of another string, it will mean it is starting to parse that string again. It will start to parse S2 or S1 or whatever. So this is how we do to parse the remaining tokens. Then, for example, here, let's take this one here, and then I'll continue with this one. I'll do it 2 or 3 more times like this one. You will see how it will, what it will produce. Okay, so now you see here, this is the first token. This is the second time. This is the second time we have that string token with capital NUL, null. And then the third time, this is the fourth time. So it is continuing to parse the same string. But if you put, instead of this one, if you put, for example, here, if you put, instead of this one, you put S1, it means you are starting to parse S1 again. So here, of course, we're going to get error here. You see, it is not coming. So that's because there is an error. Why is the error? Because you see, this is the first token. What is in the second token? It is this. But the problem is that when it tries to find the second token, there is no more tokens there. And I am trying to get anything from the string is empty. So it will generate error. That's why normally we use it through a loop. We check that it didn't finish yet. While it didn't finish, we continue. So how we do it? Okay, so I think it's already. I'll give it to you. I'll just show you just in how we do it. I said we have to do it this way. In order to parse the same string, we have to the second time, the third time, the fourth time, the 100 million time. After that one, you have to do it through this special syntax. It is not use null instead of the name of the string. Normally we use this one with a loop. So normally we use this one with a loop, and I'll show you next time, inshallah, how we convert this one into a loop. How we convert this one into a loop. Next time, I thought I'm going to cover these three things today, but it takes time. The second thing is about recursion, and then we'll use the time class to time the recursion. For the time, you ask for the time. We'll use later on, after we do the recursion, we'll try to time it, how much time it will take. Okay, so this is how to use that one. But inshallah we'll do it next time. I'll explain to you how to do the string tokenization. And normally we use this one with a while loop. I'll show you how to convert this one into a while loop. Okay, any question?
If we want to take this token,
Huh?
the rate,
If we
want to take instead token, we want to variable, not
this one?
yeah.
Normally it is just a pointer. Just a pointer. You don't need to allocate memory for it. It is just pointing to where it will start parsing. And now, when you say token, this one here, it will tell you that your word, or the word that your next token will point to the first letter of it, to the T, capital T, for this. Then when you do the other one here, it will move the pointer to the is. So it will go, this is just to move the pointer. It is not to take and copy, it is not to copy string in it. It is just as a pointer to point to where it will take the tokens. If you declare it as array, normally it is the same thing. But you will lose the memory, and you will not use the memory. Any other question? Okay, inshallah. So see you next time.